Okay, everybody, and welcome to Secondary Math 1. We're going to start the year with Chapter 1, which is Solving Linear Equations. Now, this is a PBL course, which means proficiency-based, and in proficiency-based, we always look at the standards, and when I say standards, I mean these things here that I have listed on the page. And what we're going to do throughout every chapter, we're just going to focus on making sure we know what these things tell us. So for Chapter 1, there are 4 standards, but the 2 we're really going to focus on, especially in 1.1, which is what we're starting with, are the 2 down here at the bottom. So first of all, if we start with the second one, it says I can solve linear and absolute value equations. And we're first going to start with linear equations. And then along with that, it says I can explain my steps to solve a linear equation. So as we're going through trying to solve these linear equations, we're going to explain why we're solving them, how we're solving them, and the properties and steps we're using to solve them. So moving on to 1.1, keep that in the back of your head that we're going to be solving the linear equations, and we're going to be explaining our steps in order to do that. Now, before we do that, we're going to start with some definitions. It's been a long summer. Who knows what you were doing? It's been a really long time since you've been in class, so let's go over some of these things that we should know, but that we might have forgotten. So first of all, we have an equation. An equation is a statement that 2 expressions are equal. So, for example, an equation could be like x plus 5 equals 7, where x plus 5 is an expression, 7 is an expression, and we're going to set them equal to each other, and that's an equation. Now, I forgot to mention this, so I'm going to back up just a little bit. If you're in class, I'm going to provide these guided notes for you. You just fill them in as you go. If you are doing this at home and you do not have a printer, just get a blank sheet of paper, a journal, preferably a journal, somewhere where you can keep track of these notes, and just write it on paper as we go so that you can go back and you can look at your notes instead of having to go back and replay an entire video. Okay, moving on. A linear equation is an equation that can be written as ax plus b equals 0. So for example, over here, that is a linear equation. And the key here is that you just have x. Okay, you don't have x squared, you don't have x cubed, you don't have x to the power of something else. It's just x. There's one of them, which makes it linear. Moving on to a solution is a value that makes an equation true. And that says true. So for example, if we go back here to x plus 5 equals 7, you'd say, okay, well, what plus 5 equals 7? That's 2. 2 plus 5 is 7. So your solution would be x equals 2. Inverse operations are 2 operations that undo each other. So what I mean by that is like addition and subtraction. They're inverse operations, or they're opposite operations of each other. Another would be multiplication and division. They kind of undo each other. And if you forgot that, we will go over it more. And then last but not least for our definitions, equivalent equations are equations with the same solutions. So if one solution is, so one equation has a solution of 2, you have another equation with a solution of 2, then those are equivalent or equal equations. moving on to some properties, and these are the properties that we're going to use when we actually start solving our equations. So our first property is the addition property of equality. So algebraically, this is what it looks like. If A equals B, then A plus C equals B plus C. Now, what that actually looks like is something like this. X minus 3 equals 6. If you are going to solve that, you're going to use the addition property of equality, and you're going to say, okay, well, minus 3, I'm going to use an inverse operation, and I'm going to do the opposite, and I'm going to add 3. Right there is the addition property of equality. You are adding 3 to both sides of the equation. So you're keeping both sides of the equation equal. Then you're going to say, okay, well, I'm just going to bring down my x. I know that negative 3 plus 3 is 0. So really I have plus 0. And then I'm going to have equals 6 plus 3 is 9. You don't really need the plus 0, so we just have x equals 9, and that is our solution. Next one, subtraction property of equality. If A equals B, then A minus C equals B minus C. Now again, what that actually looks like is if we have, let's say, x plus 7 equals 9. I'm going to use an inverse operation. I'm going to say, okay, I want to isolate my x. So positive 7, opposite of plus 7, is minus 7. Then I would just bring down my x. I know that 7 minus 7 is 0, equals 9 minus 7 is 2. We don't really need the plus 0, so x equals 2 would be your solution. And right here is your subtraction property of equality, because you're subtracting the same thing on both sides of the equation. You're keeping it equal. Last but not least, our substitution property of equality. So if A equals B, then you can substitute A for B. So you can substitute A for B. Now, what I actually mean by that is, let's say x equals 2. Then I give you the expression 3x plus 1. Well, what does 3x plus 1 actually equal? So I know x is 2, so I'm going to substitute the 2 in for the x, which is going to give me 3 times 2. Remember, when you put a number right next to a variable, it's another way of saying multiply. That's multiplication. And then we add our 1. So 3 times 2 is 6, plus our 1 would be 7. And right here, when you filled in, instead of 3x, you did 3 and then you substituted 2. That's your substitution property of equality. Now, using those, we're going to do 3 examples where we actually get into solving our linear equations. So, number 1, solve each equation, justify each step, and then check your solution. So, first things first. N plus 3 equals negative 7. So we need to find some number. Then when I add 3, I get negative 7. So I'm going to isolate the n. I have to get the 3 to the other side. So we use an inverse operation. The opposite of plus 3 is minus 3. So we're going to do that to both sides of our equations. I'm then going to drop down my n. I know that plus 3 minus 3 is really 0. And this step right here, you don't have to have. If you don't have that plus 0, that's fine. I actually will go back and erase it. Equals negative 7 minus 3. If you need a calculator, I am fine with that. Get your phone, get Desmos, anything you're using. Negative 7 minus 3, negative 10. Now, it said justify each step. In order to get there, we just used the subtraction property of equality. And I'm just going to write POE because it's the subtraction property of equality, and in doing that, that was right there. Now, check your solution. This plus 0, you don't need. So really what you're looking at is you're telling me, okay, n equals -10, you're done. Check your solution. So our check, I'm going to substitute the -10 in to the n, and I'm going to say, okay, -10, then I have a plus 3 equals -7. So everything up here just stayed the same except I substituted in a -10. Let's do our check. -10 plus 3, that's -7. Does -7 equal -7? Yes. Good. We checked our solution. We're good to go. Letter B. -6.5 equals P plus 3.9. Now, once again, we're trying to get the P by itself, so I have to get the 3.9 to the other side of the equation. This is plus 3.9, so I'm going to do minus 3.9 and minus 3.9. One goes on the left of the equal sign, one goes on the right of the equal sign. Now, these are going to cancel and go to 0, so then I'm going to drop down my P. At this point, I'm going to take -6.5 minus 3.9. And I am using a calculator off to the side just to make sure. And we're going to get -10.4. If we justify that step, that was also, because of right here, subtract 3.9, subtract 3.9, the subtraction property of equality, and that's my solution. Now I'm going to check my solution, so I'm going to take the -10.4 and I'm going to substitute it right in for my P. So we're going to have -6.5 equals, I'm going to substitute -10.4 and then plus 3.9. Okay, the left side is still -6.5, and then we have to do -10.4 plus 3.9. So -10.4 plus 3.9, I put that in my calculator, -6.5, check, and we're all done. Last one of these examples, g minus 1/3 equals -2/3. So I know this has fractions. Don't freak out, it's really not that bad. So we have to get the g by itself. I have a minus 1/3. The inverse or opposite of minus is plus. So I'm going to plus 1/3. I'm going to plus 1/3. These are going to cancel because they're inverse operations, and my g is just going to drop down. Equals. Now I have -2/3 plus 1/3. When you're doing fractions, they have to have a common denominator, which these do, and the common denominator is 3. That's not going to change. So really what you're looking at here are your numerators where you have a -2 plus 1. -2 plus 1, which is -1. So g is -1/3. If I want to justify that step, here I added a third, and I added a third, so that is the addition property of equality. Then we're going to check our answer. So I'm going to take the -1/3, I'm going to substitute it right back there into my equation. So -1/3, and when you substitute, you should really get in the habit of using parentheses. Whether they're necessary or not, it's always a great habit. You always put it in parentheses. -1/3 equals -2/3. So negative 1/3 minus 1/3. Again, it already has a common denominator, so we know our denominator is going to stay 3. Negative 1 minus 1, negative 2. Does negative 2/3 equal negative 2/3? Yes, it does, so we're good.